Bonjour, vous m'entendez? Oussem, do you hear me?
Oui, allô?
Bonjour.
Oui, bonjour. Alors, on a juste quelques soucis avec la présentation. On va commencer dans 5 minutes en principe.
D'accord. Je vais enlever ma vidéo. Je ne sais pas si vous me voyez, peut-être pour avoir une meilleure ligne.
On va essayer. Donc, si je fais comme ça, admettre.
Oui, c'est bien là.
Ok, on voit la présentation. Par contre,
Je vais aussi éteindre le micro peut-être pour que ça efface de l'arsène.
Donc, acheter, résultat. Il y a des gens maintenant sur Zoom, ils m'entendent pas en français. Si. Oui, allô? Ouais, ça marche.
Okay, so I don't know if I will hear you, but I make an announcement. So at 5 o'clock tonight, we are going to have a party afterwards here at the Carouge in Hotel at the Hotel 5. For those who can join us, you are welcome.
Il vient pas?
Okay, good afternoon, everyone. Welcome to the public defense of Oussem Ben Mahfoud. We will be proceeding as follows. So my name is John Henry Morin. I'm the president of the jury for this PhD. We will spend about 45 to 50 minutes with the defense of Oussem. And then we will open the floor to the jury members for questions from the furthest to the closest, ending with the advisors. That being said, the floor is yours, and we look forward to your presentation.
Thank you.
Thank you.
So, hi everyone. Thank you for coming. Thank you for being a member of the jury. Special thanks to Mr. Nabi Abdelnader and Giovanna Di Marsu for being a member of the jury and supporting me during these 5 years. So my name is Oussem. I'm going to present you today my thesis work titled Learning-Based Coordination Model for Spontaneous Self-Composition of Reliable Services in a Distributed System. It's mainly focused on connected objects and composing services on the fly. So this is the outline. We're going to go over some material starting by motivation and research question. Then I'm going to present our special services approach. Then I'm going to present our solution to compose services first using coordination model, then learning-based coordination model, and later on some improvement using quality of service. Then I'm going to present two experiments that we have designed and deployed, and followed by discussion and evaluation about strengths, weaknesses, and the limitation of our solution. And finally, we conclude with a summary and some future work. So as you all know, connected objects are being deployed everywhere. They are increasing in number. They are being involved in many domains like healthcare, transportation, smart energy, smart building. They are increased in memory, processing, and communication capabilities. That's sorry. For this work, we will try to leverage the power of these connected objects, and we will try to provide on-the-fly services from the collaboration of these objects. So we have three main architectures dealing with IoT or connected object. The first one, centralized architecture, mainly based on 3 or 4 layers. The first one is smart object. They are collecting data, sending to the cloud via a gateway. However, this architecture is unsuited for low bandwidth. It has a high cost of development and deployment. The second architecture is edge computing. The idea is to push closer the computation to the user. It provides a low bandwidth use. It is optimized for local content distribution. It improves data privacy as data are locally stored or like they are stored closer to the user. However, it needs to accommodate dynamicity in large scale scenario. And finally, the third one is distributed architecture. All we have like nodes connected together in mesh network or peer-to-peer network. This architecture enhances resolution, improves data privacy like edge computing. It provides decentralized storage and distribute computation and reduce communication costs. So this new ecosystem it stands on these sensors or like these sensors capabilities. So the next challenge is to deal with these connected objects and how we can dynamically or autonomously cooperate or make these connected objects cooperate together. So our work, the goal of this work is to leverage the power of connected objects through the special services paradigm and offer the user the most pertinent and reliable services. So special services paradigm is based or provides collective interaction among multiple entities. It is space related as data are geographically distributed, time related as data lasts for a short period of time. There is no central control, and it is suited for mobile entities. So our research questions are the following. The first one is how we explore the potential of connected objects and offer their capabilities as special control services. The second one, I don't have a remote. The second one is how can connected objects on the fly collectively and autonomously provide a pertinent service in response to user demand. The third, can we improve efficiency using a learning-based approach? And finally, how can we guarantee reliability and quality of service of the obtained service compositions? So our contribution are the following. We aim to design, implement, and deploy special services built on a coordination model. Second, we aim to design a coordination model that enables on-demand special services. Third, we aim to design a learning-based coordination model that supports on-demand services and build services on the fly using using reinforcement learning algorithm and quality of service to return pertinent and reliable services to the user. And finally, we deploy real case application using the proposed approach. So our work deal with many domains like coordination model, IoT, learning solution, service composition. We have listed related works in chapter 2 of our thesis. Here we will not go into a detail. However, like we have just to emphasize that our work, the main goal is to combine learning with coordination model, make object autonomous, and compose on the fly services at runtime. So now we're gonna move to section 2, where we will present special services paradigm and the coordination that we will use for this work. So we choose to use the SAPERI coordination model as it is well documented, open source, easy to use. It provides dynamic manipulation of data, and it provides bio-inspired coordination between agents. It is mainly composed of first software agents, which are the coordinated entity. Second, the tuple space or shared memory, which is the coordination media equals and operation out there. They are like periodically executed to provide set of chemical reactions. And finally, LSA, data structure that are controlled by agents and where we can store data collected by object for our case as we are dealing with connected objects. So this SAPERI middleware, as I said, it's not the only coordination model that we can use, but we believe it's the suited one, as previous attempt has been done to compose services before. So it provides a list of equals. These bio-inspired mechanisms are different purposes. Here we pick few of them as we think they are needed or they are helpful to compose services. The first one is bounding. It links agent with data provided by another agent. The second one is decay or evaporation, decrease the pertinence of data. Spreading, or kind of broadcast, which diffuse information within network. Gradient provide additional information about hops distance when we diffuse information. So, and finally, chemotaxis, which shoot information back to the source of the gradient. So special services are defined by set of input and output, a service logic, self-organized mechanism, and data or action provided by the object. Using the SAPERI middleware, we have agents that control the physical object, which is like sensor or actuator. It hosts the service logic and controls the LSA. These agents are coordinated thanks to the bio-inspired mechanism provided by the SAPERI middleware. So there is no need. The advantages of these special services: there is no need for central control. They are autonomous. We have local computation, and they are adapted for dynamic environments. So here we will present two applications using these special services. The first one is smart lighting. The goal is to retrieve the shortest path eliminated to a destination. So as we said, it's defined by a set of input-output. The input here is destination. The output is the shortest path eliminated to the user. Here we design 4 nodes defined by a Raspberry Pi and smart bulb. All of these bulbs are connected in a mesh network. In our case, bulb number 4 is looking for bulb number 1, so it will send or inject the request, which is the gradient, to look for the bulb number 1. When bulb number 1 retrieves or receives the request, it will send back the information to the source, which is bulb number 4, using chemotaxis. And like that, we will get the shortest path thanks to the bioinspired mechanism. The second one is special services for decentralized smart energy management. We have fully decentralized household network. Here we have 5 households. There is no central control. Each node has, we'll just stop the video for a moment. So yeah, here we have 5 nodes that present household. Each of node has is defined by a Raspberry Pi, smart bulb, and a sensor. The sensor represents the intensity of light or the electricity generated by the household. When we hide the sensor, there is no electricity generated, and instead of getting electricity from the energy provider, we will try in our scenario to get or buy the energy from other households that have excess of energy. So in this case, we have the sensor. This node will, you can see like the bulb turn off, we will send, or like this household will send a request. All the other nodes will receive the request, they will send proposal, and finally, thanks to the agent that request and contact that, how to say, deal with requests and contract, will pick the one that provide the cheapest price. And if we hide the one that is selling the electricity for our first node, so both they will turn off and they will send a new request to the other household. And here, as you see, despite the fact that the sensors are hidden, both they can get the energy from their neighbors. So this is an example to how to use special services. And in the previous example for smart energy, we saw how agents can collaborate together and provide high level of services. So the goal, or the main goal, is to leverage the power of connected objects, as I say, through the special services paradigm, compose services on the fly at runtime, and provide pertinent and reliable services. So we have seen how special services and coordination models work. Now, in section 3, we will present our solution to compose services using the coordination model. We define 2 kinds of agents. The first one is service agent, the second query agent. Both they are controlling LSA, or like semantic annotation, which is structure of data defined by 3 lists. The first is service property, which is defined by a set of key or property name. The second is synthetic property, defined by list of key value that defines some feature related to the middleware operation. And finally, list of property or output defined by list of key value with some other feature like bound query schema and use flag that we will use later on for composition. So here we will explain how bounding works. Here we have 2 agents, service agent, query agent. The service agent, let's assume that he's controlling a sensor that provides the temperature value. The query agent will inject or add a new property in the property list to request the temperature value. Using the bounding and through the tuple space and equals, you can see like how the query agent can get the requested value. You can go further by providing parameters and request property. Here we have the same service agent and query agent. The query agent will provide parameter to and request for the weather forecast by providing the city name. The service agent one can respond and provide this forecast. So we have two-way bounding. The first one to retrieve the parameter, consume the parameter, and provide the requested property, which is weather forecast. And here the query agent can get the result provided by the service. So in this slide, we will deal with generic services and synthetic property to compose services. So the composition can be modeled in graph, as we can see here. We have two services, S2, S3. S2 has A as input, B as output, S3, B as input, C as output. We have the composition diagram here. Two services and query agent. The first agent A, as we say, AB, and then BC, and the query agent will provide the A property and try to get the C property. So here's the bounding. Agent 2 will consume the A property, provide the B property, agent 3 B, and provide the C property, and finally the query can retrieve, thanks to the composition process, the C property. So here our solution support as well multiple queries. We keep the same scenario, S2, S3, the two services, but here we will deal with two agent query at the same time that they are injecting the same query in the same tuple space. So here we have agent 2 bound with both of the queries and provide the 2B property. Agent 3 will bound with the 2B property and provide 2C property. And finally, each query will get the response related to the request thanks to the dash B property and dash Q property. I'm just accepting people because we just join us. Yeah. Let's move to that. So in this example, we will deal with multiple nodes. We have 3 nodes. Each of these nodes hosts a service agent. As you can see in the graph, we have 2 services that's defined by like A as input and B as output, and S4, B as output, and C as output. Here, S2 and S3 are different, so they are not similar services. And if we request the C property by providing parameter A, as you can see here, so agent 2 and agent 3 both bound, they provide the B property, different value. So agent 4 bound with both and provide 2 different value of the C property. And finally, the query agent can retrieve. However, here he's facing 2 solutions. He needs to pick one of the provided solution. Here, in this example, we use multiple nodes thanks to the spreading mechanism that we use to keep all shared tuple space updated every time each property is added or updated. It's not the best way to do it, but we will see later on how can we optimize this one. So we have seen how to compose services, but in the last example we saw the problem is how to select the pertinent services, as we can like found 2 different value for the same property name. So we propose to use a reinforcement learning algorithm, which is a machine learning algorithm for optimization and decision making. It's defined by set of states, set of action, reward function, and state transition probability. As you can see here, to make it simple, agent has to interact with its environment and take some actions and get some feedback from users to learn and update his knowledge database. So agent learn a policy that maximizes cumulative expected reward R through interaction with environment over the long term. One of these algorithms is Q-learning, which is a reinforcement learning algorithm that allows agents to learn a policy that maximizes the reward by taking action when being in a given state. So the set of state here is defined by all received composition. The schema, as you can see here, the composition schema is defined by the requested property, vertical line, and the sequence of the property involved in the composition. Set of action defined by two actions, ignore or react. The reward function. So positive reward, negative reward can be given by the user. And finally, exploration algorithm that we have used to explore different states using the epsilon greedy algorithm that has probability epsilon to select a random action and probability 1 minus epsilon to select the action that maximizes the value of the approximation of the Q function. The Q function is presented here. It has two parameters, alpha, the learning rate, and gamma, the discount factor. So we have added the learning module, as you can see here in the agent, and the reward operation in the operation list of our middleware. So agents now can progressively update their behaviors by following what they have learned based on user feedback, and the backward reward can be transferred to the user feedback to all agents that have participated in the service composition. So here we show an example using the newly added learning module. We have 3 services. We will inject the query by providing the A property and requesting the C property. We have 2 paths to reach the C property from the A property. Here we have the Q matrix in the initial state. We inject the query, we get the response from the service number 4. We assume that he is the one that provides the pertinent solution, so we'll give him a positive reward. Here, Q matrices are being updated. Agent 2 and Agent 3 that control S2 and S3, they didn't receive feedback as the positive feedback goes only to Agent 4 that was involved in the result. We inject another query. Now we have the result returned by S2 and S3. We give a negative reward. We continue like that. Positive reward for S4, positive reward again for S4. Sorry. And now, as you can see here, Agent 2 and Agent 3 in the ignore value are or like Agent 2 and Agent 3 they are learning, as you can see here, the value of ignore and the value of react. And Agent 4, he is learning to react each time he receives this query, like the A as parameter and C as the requested property. So before we saw if 2 services are different but they provide the same value, and how can we pick the one that provides the pertinent solution. Here, if we have the two pertinent services, but the system needs to pick one of these services. So the question is how to select the most reliable services among the pertinent one. We propose to use the quality of service we measure the quality of service by using this function. The idea is to compare the similar services at runtime, decide among various compositions that they are returning pertinent solution. It increases the system reliability and we retain the most reliable solution. As we can see here in in this composition diagram. We have agent 3 is the query agent. So the same request, we are looking for C and we are providing A. We have agent 1, agent 2, they are providing the B property and they are consuming the A property. However, agent 1 has the higher quality of service, or even the highest quality of service among these two services. So at runtime, agent 4 will pick the one, or will bound with the one that has the highest quality of service. Here we ignore the agent 2 provided property and we consume the agent 1 provided property, and like that agent 3 will take the result provided by agent 4, which has the highest quality of service. Let's move to the experiment. We have deployed two applications. So the first one is sensor scenario. The goal is to request the ambient light in a given floor. So we assume that we have a set of connected objects and we are looking for the ambient light in a specific floor. Just put this away. So in this example, we will we have a set of 3 nodes. Node 1 is reserved for injecting query. Node 2 hosts 2 services. The first one is, as you can see here in the graph, we have S2S3 in the node number 2. The first node can use or can get like the floor as input, sensor as output, and then the other service get the sensor as input and the light as output. The same in node number 3. But here we get floor as input, bulb as output, and bulb as input, light as input. That's for a realistic use case. We have in smart building, for example, we have smart bulbs and sensors, and we are looking for the light property. As the sensor can measure the ambient light and the bulb can provide its level of intensity, so both we are providing the light property, we have to pick the one that the pertinent one for the user. And as we are requesting for the ambient light in the fourth floor, so we have to pick the or use the value provided by the sensor, right? So here we have the composition diagram. We have 3 nodes. We have the query. Here, agent 4 and 5, when they are controlling the bulb, they will answer first as they have the highest quality of service. We will give a negative reward to both of them, a negative reward to agent 5, and then backward to agent number 4. And then we will inject again the query, and agent 3 and 2 will learn progressively that they have to react every time we are looking for the light property, and we are looking for the light property and providing the floor property. So here we implement this scenario using we implement an application, web application to control the middleware kernel. It's not that clear, but here we are injecting the services one by one. So the scenario is it's showing in the graph. We will add the 4 services. Yes. Yeah. So here we have the 4 services. We will start by injecting the query. So we provide the floor property, and we are looking for the light property. In the composition here, we have the bulb intensity of light of the bulb to give a negative reward. Again, another query. Here we have the sensor. So the ambient light measured by the sensor will give positive reward, as this is the like the answer that we are looking for. We keep going like that. The sensor positive one and the bulb negative one. And after a few queries, our system will learn to involve or more involve the agent that provides the ambient light intensity. So the second scenario is defined by fixed node. So during crisis, many devices, objects, and services are deployed for a short period of time. Let's consider that the doctor here, the node number one, has a smartphone and he requires blood bags to be brought to his location. He does not know where blood bags are and is not aware of the current available transportation means. So in this scenario, we have the doctor that is requesting blood bags, we have two means of transfer, and we have two ICRC plans that they are providing blood bags. So the services for in node 20 are defined as follow. And finally, we have in node number 6 an emergency transport that is sensitive for the transport property, but he doesn't carry any goods. So the composition diagram is in this figure. We have the agent or the doctor that is requesting here A plus blood bags type, and he's providing his destination, like his location, which is the destination. So here we have these two ICRC plans that can bound with the blood property and provide the quantity of blood bags available in at this time. And we have a transport mean that needs location and destination, and they are ready to transport any kind of goods from the like to the doctor. So here the doctor will when he will inject, he will request a means of transport. We have two similar services, and thanks to the by measuring the quality of service, here we will pick the one that has the highest quality of service, which is in our case the drones. Yeah. So as you can see here in this example, we deal with multiple nodes, multiple inputs and outputs, complex composition, and it's not only chain of services. As we can see here, we can deal with parallel composition at runtime. So we'll move to the implementation. We use the same web application to control our middleware. We inject. So we inject the previous services, and here we will add the first query, and we will wait for potential answers that it can help us to provide or like transport the requested blood bags to the doctor. Here we get the drone transport mean. We give positive reward. Again, we have the drone that can carry the goods from one of the ICRC plants to the doctor. So during our thesis, we have been dealing with several objects like sensors, bulbs, Raspberry Pi, camera, and robots. We will move to the discussion section. So in our learning model, we have some parameters like the epsilon, gamma, and alpha, which is the learning rate. Here, as you can see in the graph, the learning rate, when it's closer to 1, our system learns faster faster than when alpha is closer to 0. Here, we pick epsilon as decreasing function just for test purposes to show how our system can adapt itself when we add or remove agents. So here we can discuss it later on. So in this section, we will discuss some strengths, weaknesses, and some limitations. So as we showed, our system is highly adaptive. It supports variable quality of service as it can pick or compose services based on the knowledge that agent learns and the quality of service. It supports multiple queries, multiple nodes, and it has or provides complex composition, not only chain of services. Some weaknesses: there is no personalized learning. The spreading is not that optimized, or maybe it's not the best mechanism to use, as when we are dealing with multiple nodes, we are using the spreading to send LSAs to all other nodes in the network. We are just flooding the network with useless data. So this point has to be discussed. Some limitation: we only return one result, as but for user experiences design, we decide to return only one result, but there is limited evaluation, as user can only be based on the composition schema and the value returned to him. We are approaching to the end, the summary and some future work. So we successfully design, implement, and deploy special services built on a coordination model. We designed a coordination model that enables on-demand special services, as we showed before. Design learning-based coordination model that support service composition using reinforcement learning and quality of service. And finally, we deploy real-case application like we see the sensor scenario and the SCFC scenario using the proposed learning-based coordination model. Some future work: we aim to deploy and test our system on large-scale scenario, adapt parameter at runtime and compare learning algorithm, build a semantic module to enhance our matching mechanism, and finally add a natural language understanding module to provide natural communication with the user. Some potential impacts: so our system can be used in large number of domains, like social distancing for COVID-19. We can put some objects, and these objects can sense sick people, and then they will diffuse information to other people to avoid some locations. Energy sharing, as we saw before. Smart city, emergency situation, and robots like traffic steering using collective interaction. For smart cities, you can imagine one application like someone is looking for someone to cut the grass for him in the garden. Another one has the material to cut this grass, and another one is ready to transport the guy and his material to one location. So we can compose many services at runtime thanks to our system. So we published 3 conference papers and 1 journal paper recently in March in the International Journal on software tools for technology transfer. So thank you very much for your kind attention, and I'm looking forward for your question and comments. Thank you.
Thank you very much. So we will proceed from the furthest away. Do we have Toulouse online, Professor Glazes?
Yes. Yes.
Hear us? Okay. So the floor is yours for your questions and discussion.
Okay, thank you very much.
Thank
So
you.
first of all, I would like to thank the supervisors, Nabil and Giovanna, for inviting me to evaluate this work. Thank you, Hussein, for taking into account in your manuscript, the new one, our request for changes. And thank you also for your presentation, which was very clear and pedagogical. So I have some questions about your work. The first one is about the matching process you speak about at the end of your talk. The agents analyze the query to find the query which is more sensitive to their properties. And I would like to know what mechanism you use now. Is it a syntactic comparison at this time?
Yeah, right now we are using syntactic matching, but we are working on for like new paper, and we are working on enhancing our matching mechanism using semantic matching.
Okay, and so my question is, this step for me reminds the filtering step in expert system in 90 years. And so I would like to know, it is a very time-consuming operation. And do you have some problem with this, the duration of this step in your system? And perhaps no, because you have few agents, but if the number of agents increase, what do you think about this limitation?
So, yeah, I see your point. So actually, if we are, as we are dealing with many nodes, so the computation is shared on all these nodes, and each node hosts few services. So if we can go up to, I don't know how many services per each node. I didn't make the, as I said, I want to go and deploy and test our system in that scenario, but in one node, having like multiple agents, the matching is not that low or like slow. So I think it doesn't matter that much for the performance of our system.
Okay, so because in nodes you have few agents and few services.
Yeah.
Okay, okay. So after
because nodes are like Raspberry Pi or mobile phone or something like that, so they are not supposed to deal with hundreds or thousands of services.
It's more or less the same question about my problem is scalability and the number of agents you can have in your system. And in the self-composition process, the services requests are sent to all the nodes and of the network. But you can imagine that you have several processes of composition in different nodes, and they send all together the service request. So it is also a scaling problem. No, you think cannot arrive?
For sure, somehow we will be faced to a scaling problem as we will deal with many agents at the same time, many users as well. So we will have like different composition taking place at the same time and also at the same nodes. For sure, at some point, it will get its limits for sure.
Okay. So after I have a question about the evaluation of the quality of service. So you evaluate it in terms of time, cost, availability, and reliability.
Yeah.
And so in the slide 30, you have different parameters W1, W2, and so on in the formula. And my question is, but I think it's a limitation also, if you have several users, these parameters, in my point of view, are linked to one user only, no? Or you can have some kind of parameters for a group of end users, or?
So yeah, as I said before, there is no personalized learning. At the same time, there is no personalized quality of service, because as we can see here in the formula, there is a weighted that can how to say, like modify. However, in the way how we implement it, it's fixed.
Right.
But in the future, it can be adapted depending on the needs or of the user. So it's this kind of parameter. It could be variable for each user. However, it will impact the learning process, as we will, for each user, we will pick a different composition, and we will get different rewards for different composition. And like that, I think it will.
Okay. So
Yeah.
if I well understood, if I well understand, you say that these parameters can be learned.
No, I said they have a direct impact on the learning process. As if we can modify or like allow to the user to modify this parameter, it means like every user, if we will pick, if someone is in need like the less expensive, for example, or like the faster service, and the other one is looking for the most reliable one, our system will pick two different composition. And each user he will give, or like positive or negative, whatever reward, and our system will learn different composition for the same request, and like that it will be confused. As I said, there is no personalized learning. If we will add the personalized learning, like that we can allow user to play with this weight.
But it's a very important part in your system, because it's to deploy in ambient environment, and in this environment there is several users. So it's very important for me to improve.
It was a long discussion about personalized learning. We said, like, usually people, we have this kind of emergence of the system if we have different users. So we hope that all users, they are looking for the same result. For sure, we have like some other users, they need like different results if they are, and they are looking like injecting the same query. But I think this is democracy.
Okay. Always in the evaluation, the end users provide feedback to the system.
Yeah.
So I agree, it's okay for the first version of your system, but do you think that feedback is a solution which is constraining application for the end user, no? And do you think a way to evaluate, or to evaluate the action of the system without the implication or a strong implication of the end user? Is it for you something very important, or no?
Yeah, but let's see the problem from the beginning. We have like many services, and we need to compose these services, and we have to provide the most reliable and pertinent solution to the user. If you will try to put some knowledge on our system, we have many different, approaches. We choose to use the learning approach. We have three kind of machine learning algorithms: supervised, reinforcement learning, and unsupervised. Unsupervised, without having feedback, it will be so hard to the system to learn something. The supervised will not deal with the dynamic characteristic of our system, but we choose something in the middle, as the user can be involved in the composition, and it can give some how to say the direction to our system to learn and to return something like it's not the most reliable and pertinent, but something that can be suitable for the user. So this is like our approach. For sure, I guess like there is other other approaches that can be used to compose services. In the related works, I list few of them, but usually the paper that I read before, usually they are based on predefined composition schema, and they are comparing all similar services using like genetic algorithm or like something for optimization problem or learning as well, Q-learning to pick the service that has the highest quality of service, but still in predefined schema, they are not composing the schema at runtime.
Okay. It's okay. And yes, I would like that you highlight what are the consequences of your work on Sapere. Do you add something in Sapere? Do you modify, or do you only use Sapere?
So
I saw, yes, a slide on this. Yes.
So first, Sapere is like a huge middleware that provide different mechanisms and services to different purposes. So the first step, we took over the Sapere and made it lighter to be adapted to the IoT environment, as we are not dealing with high computing machines. Then we adapt some structure, like as I said, LSAs and other operation. We pick a few bio-inspired mechanisms, and we add the reinforcement learning module to the agent, the reward in the operation, and we made some enhancement to the Sapere that to be able to finally to compose the services, as Sapere is not a coordination model that was principally made to compose services.
Mm-hmm.
It's designed to deal with mobile entities in pervasive systems.
So thank you and congratulations for your work, which combine existing concepts and techniques to contribute to go further to the collective adaptive system. So thank you.
Thank you. Thank you.
Thank you very much, Professor Glazes. We will now move to Professor Elhaj Ben Kefika. Can you hear me?
Yes, I can hear you very well. Yeah.
Okay, so the floor is yours, please. Thank you.
Thank you. Thank you. Congratulations, Hossam. Good to see you, Professor Glazes, Nabil, and Giovanna, and everyone attending here. Congratulations, Hossam, for getting to this stage. And thank you for the supervisor for the invitation, and also for the great work. I went through the modification of the thesis. Thank you, Hossam, for making those changes. I think it's more cohesive now in my own view. I've got only a few questions really, and I'll try not to repeat what Professor Glazes has already mentioned. But a clarification on a multiple user issue. I think I agree with Glazes. This is a very important thing. You mentioned a speculative approach to make it, adapted to this user needs. How would that be implemented? And how can you make sure like you get optimal performance there?
Okay, let me.
This is the multiple users issue, yeah.
Yeah. So here we, as you can see, there is like the few matrix for each agent, and all users are involved in the composition, and they are giving feedback to the same agent, and the value are updated without taking in consideration which user give the feedback. if we move from two-dimensional dimension matrix to three-dimension, we can have a personalized learning by learning what we have to return for each user, and we are taking only the feedback provided by the user. So we will have personalized knowledge per agent per user.
But do you have to compromise any services there? I mean, if you have any conflicts or something, do you have to enter any compromise?
So if we will move to a personalized approach, we will not have any conflict between users. However, here in this approach, we have some conflicting problem. And as I can show you some slides here that showing how agents. Just one moment. Yeah, here I don't know if you can see the. So here we check how agent can react. So if you are giving only positive feedback, as we can see here, the agent, it's so easy task for him to know what he can do. However, for in the last chart on the right, we can see conflicting feedback. And if one user inject the same query and give positive feedback, after a while another one came and give a negative reward, so our system just will oscillate and it will just return a random result, as he can't learn from
what is we said as if you have multiple users you will not have conflict in what's your justification for that?
No, I said it's one of the weaknesses of our system and one of the limitations. We are aware that it's problem for if we have multiple users, and if we will get a conflicting.
Yes.
However, if the majority decide to to pick one direction, and there is one user is how to say sending the opposite feedback compared to all other users, our system will not care about this feedback, as we can push our system to learn faster or slower, and in using these parameters that we fix regarding our use case.
Okay.
If we pick higher, so our system will learn faster, and if we pick alpha lower, it will learn how to say slower, but one conflicting feedback will not how to say will not decrease the level or the quality of the knowledge of the agent.
Great, thank you. You have mentioned in your for your system, you mentioned that for the when you adopted your bio-inspired solutions, you use the word robustness, adaptability, and optimization. So how did you actually quantify robustness and adaptability? Did you actually get to quantify them? You modeled them or not?
So bio-inspired mechanisms, they are known to provide robustness and adaptability, as there is no central control. If one node get down, the system will keep working, and even if one node was involved in one composition, thanks to this bio-inspired mechanism, our system can get right from this node and can try to explore the environment and select different services and provide a new composed services to the user without the intervention, or like a human being intervention, it will adapt itself at runtime. So this is what we call robustness and adaptability.
Okay, and you think that you've achieved that through your solution, correct?
Yeah, for sure.
Yes, and how can we generalize that robustness? Is it generalizable, or is it only by the evaluation you have made?
So as we can see here, for example, in this
Yes.
here we are dealing only with one node. So we have many services, and we add at runtime we add services. So as we can see here, we have like, I will not explain the scenario, but here as you can see the composition, when we increase the number of agents, they are directly involved in the future composition, and the number of composition are increasing. And at the same time, in the other graph, when we are removing some agents, directly our system is adapt itself and provide the composition that can provide to the user.
This is very good. Yeah. Okay. Now go to slide 30 again. That's okay.
30. So yeah.
Yeah. Okay. The optimization function here. Okay. Sometimes you don't care about the cost, and sometimes you don't care about the time.
Yeah.
If you know that's sometimes a trade-off, isn't it? You may have the money to if you want the services urgently, you don't care about the costs.
Yeah.
So how this optimization will not provide you with that trade-off?
Not for this version, as we have equal
fixed weights.
Yeah, same weight.
Same weights, yeah.
Yeah.
Okay. Did you try to look into, because sometimes, as I mentioned, maybe reliability and availability is maybe you want them both to be there, okay?
Mm-hmm.
But in terms of cost and time, as an example, sometimes we trade between those, isn't it?
Yeah.
So the weights there, when you put them equal, does it give you an optimal solution, or is it just for testing purposes?
No, it's only for test purposes. But we made this function like we did. Actually, as we are not asking the user to change these weighted, and we didn't really discuss in details the use of this of the quality of service. So we proposed to design and made it like available for further works. However, we are aware that this weighted or this weight has to be adapted, but we are not sure if we need to ask the user to adapt it, or to fix it, or should we implement like something that can be optimization problem to solve this kind of problem. As you said, sometimes we don't need, like, we don't care about money. Sometimes we need, or we care about time. So it's really a question, and I put it in the future work. And this point has to be resolved to if we are dealing with.
Yes, exactly. I think yeah, it's interesting. Yeah, it's interesting that you pick that up, because I think this multi-objective optimization, I think, can give you more trade-offs, or can give the users more trade-offs between the objectives that they can select based on their needs. Again, when you talk about the needs, time and cost is a need, is one of the needs, isn't it?
Yeah.
I think we can provide them that choice. You mentioned in your strengths of your thesis, variable quality of service and complex compositions. So what did you mean by variable quality of service here?
I mean,
and how do you define that variability?
Yeah, our system can, I will go back to the previous slides. Where is it? Yeah, this one. Yeah, so let me show you on the screen here. So here we have two services, two similar services. They are providing the same value. It's supposed to be the same value. And the agent 4 here will bound with both of them, and then will pick at runtime the one that has the highest quality of service. So if in the next query, agent 1, the quality of service of agent 1 decrease, agent 4 will pick the provided value by agent 2 as it has the highest quality of service. So even if the quality of service are variable and for some reason the service that we used to use has some problem, and even if we learned already that we need to use this one, if we use this quality of service, the system will pick the one that has the highest quality.
So is that not adaptability?
But no, it's not adaptability. This one is like dealing with variable quality of service and pick the one that has the highest. Okay. But adaptability is on learning, as we are using an exploration algorithm, and if the agent learned to react, but a new agent or like new. Okay, let me explain here. If we have, for example, in the same, so variable quality of service, it's clear. So we can pick the one that has highest, and even, but the adaptability here, if we have in this graph, we have so A, B, and they have S1, S2. They are similar, and we learned for some reason we learned to use S1 and S4, right? Then. After a while, there is a new service that has been added to the system, and it can directly provide the C property when we give the A parameter. So if we imagine that we have a new path to reach the C property, this new service, the agent that controls this service doesn't have any knowledge yet. So he's here, and our system, thanks to the epsilon greedy algorithm, from time to time, he will just try different compositions. And if the new added service provides the C property and the user found out that there is a better solution that can be provided to him, he will give a positive reward, and like that, the new added service will learn, and the system will convert to the new service that has been added, and the previous like two services that we used to use before, they will start to get a negative reward, and they will have a step back without. They will learn to ignore finally, and
but for the variability of the quality of service, there is a decision-making process, isn't it?
Say it again.
For the variability of the quality service, there is still a decision-making process to select the service.
Yeah. So the decision for quality of service is made by the agent.
Yes.
During the composition.
Yes.
However, for adaptability, the decision is made by the agent during composition as well, but based on the knowledge that they have, that they get before.
Great, thank you. And you mentioned complex composition. So did you do any complexity analysis for that?
We didn't get that much on details.
Okay.
However, yeah. So
would that be useful, you think, if you do complexity analysis for the? Would that be useful?
Yeah, but we said complex composition as we are doing parallel, and as you can see here in the graph, we are doing
you just use the complex as a literal. Okay.
Yeah.
Okay, that's fine.
Yeah.
That's okay. That's okay. Obviously, my last question is you've mentioned it clearly in the research limitations is scalability and the lack of evaluation. I think I'm not going to go through those. You know, I think you realize that scalability is an issue, and also now my final because of what we are going through these days, the COVID-19. One of the applications you mentioned COVID-19, but it was not clear how was your system applicable to COVID-19.
So yeah, the idea is, okay, let me go, but yeah. So the idea
No, I'm just trying to understand. Did you just stick it in because of, or?
I mean, imagine if you have many objects deployed everywhere in the city, and this object can sense like mobile phones, and using this new mobile phone application that they can
trace and track.
Trace, yeah, exactly, trace these sick people. And like that, we can, for example, we are at home and we need to go somewhere. And using our system, we can send a request looking for shop, for example, and using a routing application, for example, we can avoid all these, how to say, all these places or areas that could be or might be infected by the virus, thanks to all these connected objects deployed everywhere in the city, for example.
Okay, so these objects, they can detect suspected people, is it?
Exactly. We imagine that they are smart enough to have some data, collect data from the people passing by, and from transportation mean, from data from each neighborhood, and like that, if we request to go somewhere, we can avoid some places to or like provide the safest path to our destination.
Okay, that's okay. Thank you very much. That's all my questions. Thank you.
No, thank you.
Thank you very much. So next is Luis.
Hi everybody. First of all, thanks for the presentation, and thank you, Anna, for inviting me to be here. So in 2011, I joined the University of Geneva working in the Sapere project. So there we some way we implemented the basic of where this work stands at home, the Sapere middleware and the Sapere coordination. I see a clear contribution in the way of adding self-composition, so the extension of the coordination model to support self-composition, the fact of improving efficiency with learning, and ensuring the quality of services. And I really appreciate to see that this improvement has been validated and approved in peer-to-peer conferences and donors. So I really appreciate it. I see also that you have opened new potential case studies for the coordination model, what I think is very interesting to see as well. I have one of the questions I have. You showed here the potential of fully decentralized approaches, architecture.
Yeah.
So we talk about the better scalability, adaptation, failure tolerance, something I have been showing in my research many times. However, we see that when industrial solutions are applied to case study like the one that you show here, most of the time the solutions are centralized or are cloud-based. Okay, that's what normally when you implement solution for coordination of different vehicles, coordination normally is internet connected and you have central server that handle.
Yeah.
Very close example here was a company called Orbitwise, was a startup here 5 years ago. They wanted to have Internet of Things sensor all around Geneva, like 2000. And the solution was to have an antenna on top of Salem to connect all of them and extract information. I'm wondering what is missing in your opinion in order to move these fully decentralized approaches like the one that you presented from potential impact in application to have real application.
Yeah, I see your point, but I guess you have been dealing with this communication problem between all these connected objects since like many years now. The same for me. I tried to always connect object in mesh network. There is many communication protocol in Manet segment, let's see, that can be used, but still they are not that efficient to be to provide how to say a reliable application. In practically speaking, I was always connecting or maybe or like building my network like manually. Still, I have to connect all objects together in an ad hoc network, and then I try to. But if a new node are has to be added to the network, still I have to make the update all the network, all nodes in the network to communicate with this node. Uh, More problems come if we are dealing with not Raspberry Pi but mobile phones. Some restriction made by the Googles and Apple, they are not allowing any peer-to-peer communication between mobile phones. There is like this, how to say, direct Wi-Fi protocol, but it supports only like I think up to 2 or 3 devices. I think the next step probably with 5G and all these connected objects that we are talking, and they can communicate, collaborate, and maybe we were like, we shouldn't be based on fully decentralized architecture. Probably edge computing could be more realistic, as we can go through internet and use internet to communicate all network together, and all connected objects can be directly connected through other communication protocol like Z-Wave, LoRa, whatever, to this edge nodes. But back to your question, this decentralized, I think at the moment they are not ready to be or to be put on the market. I don't know if you share the same point of view.
Yeah,
totally
agree.
Yeah.
Totally agree. We faced similar challenges when we went to 2015, 2016, trying to move to the industry that solution. And even though we saw the potential of being applied in many applications, we didn't find the way of really implementing, mainly due for a lack of middleware and low-level protocol allowing the communication.
Communication protocol, maybe, yeah. There is LoRa, it can be used in mesh networks, but still LoRa we can exchange a high amount of the bandwidth is so limited, so we are just exchanging like few bytes, and I think these kind of applications are not suited for this kind of protocol. So we need to pick another protocol. I don't know, like Bluetooth. There is no that wide range. If we go to Wi-Fi, I don't know, it's like a good idea as it consumes a lot of batteries, but at the same time, we have a wider range. We can go up to, I don't know, like 30, 40 meters. But if we need like a case of smart cities, maybe we have to connect building, but at the same time, we don't have the suited protocol that can connect this building. We have one, but still we have problem with data. So I think maybe could be like optimistic. Maybe 5G can resolve all this problem, and like that we can directly move to the new generation of IoT. No? Yeah.
The problem is that LoRa is more right and are uploading out. Why you have this IoT synchronized. What there are really ways to take and complete the LoRa protocol in order to have the kind of security at the level of the LoRa data. And this ends up with what we can.
Thanks a lot.
Welcome.
So I think that's all. I really appreciate your answer.
Okay.
Thank you very much. Now moving to the advisors. So please, Professor Matthew. Thank you, Sam. I think all have said almost. So I have maybe two comments. One is an my first comment is related to what qualification. When you say that returns returns one,
yeah,
is that an indication for a consequence of the decision that this is a fully autonomous? If you have for semi-autonomous system, you have kind of several answers. And you decide. So is it a limitation or a consequence or result of your decision to have a fully autonomic system?
Yeah, well, I mean, when I was working with Giovanna on the design and also with you, we said we were facing the design problem. Should we return only one result per query, or should we return the whole list of results and the user can pick one of them or maybe reward all of them? And if we will choose the second approach, it will be like, I think it will be like disaster for not only for the user but for the latency for the system, as we will carry on all the compositions and we will diffuse all the composition being done on the system, and then the user has to pick one of them and then give backward reward to all the agents that composed, and like that the agent, I mean, friendly for like a better use of the application. I guess the user, when he is requesting something, he needs to get just one answer. He doesn't care about what is being done behind the scene. So that's why we said, okay, the return only one result. It's so much lighter for the system, and after a few queries, the system will learn at some point. It doesn't need to learn with many rewards being or giving to the system. However, returning one result can be also confusing to the user, as if you will inject a query and he's waiting for a result, he will get the result, but he doesn't know if there is any future or like better result that can be returned to him if he will give like positive or negative reward. And this is quite annoying for the user. And sometimes, if we are using also this exploration algorithm, sometimes the most pertinent and reliable services exist, but the system doesn't return as he chooses to pick a random composition. And the user, at some point, he's a bit confused, and he doesn't know, should I like give a negative reward, or should I pick this one and it's okay? And also, he only can evaluate the result based on the value and the composition schema. So if we imagine large-scale scenario, as we said, and we have different composition and a large composition, the user, he will not care about all the composition schema that is returned to him. He will only care about the value, but doesn't make any difference if he's looking for the temperature and we return, for example, 29 or 28. Which one should he pick? Or he will evaluate one, but he will say just, okay, I guess this one is the most pertinent one. And I think that's why I put limitation, because it's quite annoying to the user.
My second comment is related, sorry for this slide 30.
Again.
Once again, yes, last time I promised.
I don't know if Giovanni will say a slide or not. No, just to say that the formula you are proposing to come on for the first question from Professor Marie-Pierre Glass, we can personalize, customize this function per user. It will be an extension of the work, no?
We can, but as I said, the same answer. It will have an impact on the learning.
Yes.
And like that, we will get some conflicting reward, and the system will not. For one user, he's learning to return one composition. For the other, he's learning to return. So he will be like maybe.
This is what you call democracy. No?
I mean,
so
no.
I have a kind of knowledge per user. I'm customizing my reply or my answer according to the user or to the request coming from a group of users.
Yeah, like that. The system like that will learn two compositions, both they are pertinent, and he will pick the one that has the most, depending on the user. That's right, and like that you will switch between political parties.
Okay. So my little anecdote is related to slide number 14.
14?
Yes, and the memory comes back to me when I see this slide 14, and you were fighting with these lamps and raspberries, trying to connect them.
Yeah.
Wonderful.
I see. Yeah.
Complaining about everything and nothing. It was 5 years ago. So today you are, I think, more mature, and we see the result here. So congratulations.
Thank you. I see what you mean.
My office was just behind. I'm seeing struggling, fighting, crying. So congratulations.
Thank you.
It was 2015. Thank you.
Thank you very much. And,
okay, so thank you. So first, thanks everybody to agree to be in the jury members. I've done a very great job asking a lot of questions and improving the work. And I also want to take this opportunity to thank Hussein and also Nabil, because in 2015, Nabil approached me saying, I have a PhD student. No, I have a
promising master student.
I am a promising master student, and I have some funding from him, but can we do a PhD together? I had no funding, but we could do the PhD. And so that's how we started the collaboration. So I think it was very good and very useful. And also at some point, we sent here and started working as a teaching assistant. And I would say that, okay, we don't see this. It's not part of the research work, but it has been very helpful with the teaching, with the students, bringing concrete tools to develop all these types of systems, also at the level of the teaching for the students. So this is very precious and very useful. And I'm already worried when Steph is going to leave because I don't know how it will. Okay, so this said, so thanks Steph for this work and also to bring, let's say, something further the next step. And okay, I must say we had also already all these discussions about personalized learning, about the quality of service should be like 1 or 2 or all the results all together and should choose back. So this is one possibility to do it. Of course, we are aware of others. Okay, I do not have too much questions. Maybe one, okay, some little points to go a bit further. How do you think you could be with this work far from starting a startup? about this. This could be an idea. It's close to that level of competence. I don't know.
Yeah, good question actually. And you are always thinking about how can I exploit the knowledge that I got from these 5 years working with SAP and trying to compose services on the fly. I think the limitation I discussed with Josie, there is no way to continue with this decentralized architecture if we want to go to the market. However, I think if, as we are dealing with connected object pervasive system, we can go, I mean, further and use also available services. As I said, the example of the garden, or like whatever for the music, someone is like looking to deploy some, you made like some party here in CUI, but he doesn't know anyone who can play music. He doesn't know anyone that can install all the equipment needed for the party, and at the same time he doesn't have transportation, and he needs someone to bring this equipment to him and bring also the guy who is playing the music. So we have 3 services that can be composed at runtime if these services are available. But it can be composed, not only applied for IoT, but applied for general services. We will, how to say, we will, I mean, we designed for all for like IoT connected objects. If we will move to web services, still we can connect these services, and if we add this semantic module, it could be also a good idea to provide complex or composed services at runtime to the user. So we can imagine like a platform, like a research engine, but not for like result or response or like Google, but we can implement a research engine research for services, and behind if he doesn't in the system, if he doesn't have the right service, he can compose and try to imply all the, how to say, all the actors or like potential actors in the composition to provide service to the user. So this is one of the use case, but I think we have to see if it's, I mean, instead of having this kind of announced websites or applications like AnyBees or whatever, we can, instead of looking for an English teacher, we said, okay, I'm looking for a teacher, English, and the system can compose a driver and the teacher and maybe a blackboard or whatever together and propose to the user to all these services. So pick one of them, and then it will update itself regarding the user feedback.
Okay, I thought this is the second question. So this is, let's say, extend a bit for the type of service and in the street for everybody. So there is the other aspect of natural language and semantics. So according to you, how far we are from us? So I mean, if I go back to, for example, before where I can Google a service instead of having to rely on the syntax, I can do that. Someone says teacher, someone wants like enseignant, and then I get everything. So the question is how far you think you are from able to?
I mean, we can do it, but I don't guarantee the efficiency of the system, as we will have some error in the when we move from the natural language to the query language, and then if we will add the semantic matching, we will get another error rate or small percentage of error to reach the right query and the composition. And taking in consideration that with this kind of direct query or syntactic query, we have already some problem in the matching and in returning the most pertinent solution. So I think in terms of percentage, maybe it will, the reliability or the accuracy will decrease a little bit. But the other problem with the natural language understanding is we can't understand or like transform all the query or the question made by the user to the right how to say query structure. As here we are proposing something that is adapted for all kind of use case and scenarios. We can ask whatever we want, and the system will try to pick the services that can respond and maybe a solution to the user that can suit him. If we will add this natural language understanding module, we have to build a huge how to say set of how to say dictionary to finally to try to translate all the question made in natural language to the query. And I think if we will move to if we will implement this kind of or add these modules, we have to focus on only one how to say domain or scenario.
Okay, thank you. So I also just want to compliment. I thank the organizer for this question on COVID-19 because since we are locked down at home, I was thinking a lot about what I'm pretty sure we can do something. And so we started brainstorming. Hussein also in answer to the current Swiss solution, which is the app Swiss COVID, which has problems data protection. And some a lot, okay, a lot. And so what I wanted to say is that in addition to also, we don't even need to know who is sick or not. In fact, we just need to know where are people. And we could steer people to avoid crowds. And Jose must probably remember that the first applications of Sapere were crowd steering. How you kind of always the same idea, but with objects, maybe when you go in the tram, push a button saying, I'm here, guys. I am in the tram. Sick or not sick, you don't care. And then you can say, the tram is an object and can answer that. So many people in the tram avoid this place, avoid like density. Yeah, for the density. In addition to sensing the mobile phones or anything, yeah, we can imagine a lot of variety of usage for the COVID.
Did you call that, sir?
Not yet. I didn't tell our minister. I will do it as soon as we finish. Okay, so thank you.
Thank you. Thank you very much, Giovanna. So thank you. Maybe as president of the jury, I can have a kind of an overarching question. Could you put the slide of the future? And yeah. Just before. Just after this COVID. Right. So obviously, the focus of this work was not on security. No, but IoT, smart cities, health issues, all these situations today will be profoundly impacted by the way we design the systems for tomorrow. Definitely the privacy by design, security by design, privacy by default, people are talking about it. It's not quite there yet, but I think there's some form of progress. So my question here, we're looking at basically kind of composition of services in a dynamic environment. All of these scenarios are very important, very good. But if nothing changes, it's going to be a nightmare, even worse than we think. Black Mirror is just only the tip of the iceberg of something that could really go sideways and really incredibly bad. How do you see now, if you were now to pursue all this, given the importance of, because you still talk about reliability, from a quality of service standpoint. Now, some people will argue that security is part of quality of service. So, how do you relate? How do you relate to all this, and how do you see evolving your work in this context?
Actually, we were like talking about security from time to time about IoT, and all the time we were avoiding this this topic. And okay, this work we will not deal with security because it's like a long way to convince people that we can deal with this kind of problems. But I think in our system, as we are talking about like software level and in the network level, there is already an issue before security. We have an issue of like communication. So probably that's why we didn't like deal or with this kind of problems, as these connected objects can't communicate right now together. Can communicate for sure, but
it's not a criticism.
I know. I know.
How, if you were to think about it in the future now, if you take your work and you put it kind of work, how would you go about this issue?
I mean, as we said, like data privacy, as we are locally storing the data in the user device, for example, it could be one of the solution to avoid all these data exposition to the we are avoiding the cloud already. It's a good point. There is no central storage where we can do some analytics to analyze where people had been or whatever, or what they are looking for. So we are trying to get rid of this big high-tech control on our daily life, and we are trying to have in smart building. No one need to know that I turned on the light or turned off the light or the shower or whatever. Why should I like the sensor is right here? My smartphone is here. I should go via internet, go to San Francisco server, blah blah blah, and then control my device to say, okay, now I have to turn the light. So if I can communicate directly to, I don't know, whatever smart node here, like Raspberry Pi, and directly the communication is locally stored for privacy, I think it's really a good point.
On the other hand, you mentioned that massive decentralization is not practical.
It's not practical, and they want. Yeah. But still, in the middle, there is the edge, and we can have like some local network, ad hoc network, for example. We can connect all our devices with a central node locally deployed, and we can control, for example, our building using this fancy communication stuff. But still, we keep our data close to us. We don't need to share it with anyone.
Thank you very much. Thank you. Good for thought. Okay. Would anybody who has a doctorate would like to pose a question in the audience or online? You have a PhD. It's a tradition. I never knew why it's only people who have PhDs who get these questions, but I think everybody should be able to ask questions. The rule is that way.
I can quickly ask more. So in general, I say your experiments, different using different methodologies of learning.
Yeah.
Maybe I might get lost. What's the state of the art or in your system? What is the best comparable example? So you have your system that you describe and you want different experimentation. What would be the competitor? Google search. Is it what is it? Tangible way? Just
okay.
Yes.
It could be if they are working on the same, but I think right now people they are trying to compose, as far as I know, people they are trying to compose services usually based on predefined schema. So imagine we have the travel planner. We have to take the plane. We have to book an hotel. We have to book transportation mean. We have to book some trip. And usually we have this composition schema is built, ready, and we have different hotels, different transportation mean, depends on the cost, on the reliability, on the comfort, and how the system is trying to, if we are looking for the cheapest price to go for a holiday, he's trying to propose or suggest an hotel transportation mean. This kind of solution are, you can find many paper working on this kind of problem. But as far as I know, using coordination model, learning solution to compose services on the fly, I think we don't have competitors, I think. So, and I think it's one of the reason maybe, because it's not like a direct way, which we have a lot of problem and limitation, as I said, in the design that can be an obstacle for the future to continue with this kind of solutions.
Okay, so thank you very much. Dear audience, remote and local, we are going to another place for the jury members. So don't run away. Anyways, it's raining outside, so you have nowhere to go. So the people who are online from the jury members, you have received the Zoom link from Giovanna. So I suggest maybe we just convene on Zoom in 5 minutes so that we can make a technical break. And then we will be back here with everyone.
Sure.
So thank you.
Should I turn off the Zoom?
No, you can leave it for the audience. Okay, yeah.
Okay.
We'll all be coming back. Huh?
Mais félicitations, Oussem.
Hassan.
Oui, frère.
Ça va, mec? Tout va bien?
Ça va. J'étais là en ligne, hein?
En ligne, ça va, ça va.
Félicitations.
Ça a été?
Je suis fier de toi.
Comment tu trouves?
Bah oui, c'était top, je te jure. Wallah, c'était top.
Parfait.
Je suis content pour toi.
Merci
Et,
beaucoup. Hein.
ouais, félicitations à Alan aussi. Hein. J'étais pas là ce matin. Et puis,
C'est ça. Ouais.
How are you doing?
yeah, I'm good, man. How about you?
I'm doing great.
Hey, congrats.
Thank you.
On aurait dû quand même avoir Mehdi avec nous.
Ah ouais.
Ah ouais.
Numéro 206.
Mais si tu veux, une fois, on peut aller sortir boire un café avec lui.
Ouais, on va faire ça. On va faire ça. De toute façon, là, je pense que tu es toujours dans mon quartier, non?
Ouais, toujours à plein palais.
Ouais, maintenant, on va essayer de faire ça. Et puis, mais en tout cas, félicitations. Puis, j'ai ton numéro, je vais t'écrire. On va faire ça. Là, bon, quand je vais me demander de venir tout à l'heure à l'apéro, tu diras que je ne pourrai pas, malheureusement.
Ah.
Là, je vais quand même faire les courses.
Mm-hmm.
Et puis voilà. Et ouais, je vais voir avec Mehdi et puis on t'écrit.
Ça marche.
Ah, ciao, Sam. Félicitations encore.
Congrats, man.
How was it, man? Huh?
Very nice.
At the beginning, I think it was a bit laggy, but then No?
It's okay.
Et félicitations Oussem. Hein.
Merci beaucoup.
Ouais, c'était très bonne présentation. Je comprends pas les détails, mais alors j'ai trouvé super bien fait et très bonne structurée, bien clair et tout. Hein.
Parfait, merci beaucoup.
Moi, je pensais que c'était que en ligne. J'étais surprise de voir qu'il y avait quand même des gens dans la salle. Hein. Comme j'ai vu le message avec le Zoom, je pensais que c'était que en ligne.
Ah, non, mais au début, on s'est dit on va faire en ligne, mais après, on a dit c'est triste quand même de faire les deux en ligne, privé et public. Donc, on s'est dit allez, on se partage.
D'accord.
Moitié.
Super.
Merci beaucoup en tout cas.
Bah, bravo. Hein. Allez, bye bye alors. À bientôt.
On va sortir si jamais boire un verre, mais je ne sais pas si...
Bah, là, je ne suis pas à Genève, mais la semaine prochaine, je viens à Genève. Mais... voilà.
Yep.
Sam,
Wait.
congrats, man. How are you doing?
Hey. Comment ça va?
Oh, toi?
Yeah, ça va.
So the paper you mentioned is ours.
And we have the deadline end of September.
Yeah, next month. Yeah.
Are you back to Geneva or still in Italy?
No, still Italy. But next week I will be there.
Okay, we can meet in.
Yeah, then we can meet.
Let me know when you're ready.
Yeah, for sure.
How was it?
Cool. But yeah, but now the situation is getting worse. Like the. So yeah, I don't know.
You have to do the quarantine when you arrive in Geneva? Or?
No, I think no. I mean, they know. Tomorrow, maybe yes.
Okay.
No, but for Italy, there is no quarantine now.
Okay, I see. But how about the presentation? How was it?
Presentation was cool. No, it was good. I think it was clear and no, it was good.
Okay.
But this, you also have the private one?
Yeah, I did the private one mid of July.
Ah, okay.
Yeah.
And then it was done.
Yeah, in the private one, they said, okay, everything is okay, so we can move to the public one. The public one was like for showing off. See?
Exactly. So how is UI? Empty.
I mean, it's empty, it's raining outside.
Raining?
Yeah.
Oh my God.
It's 20 degrees.
Yeah, it's so warm.
You have to enjoy the last days of
Exactly.
coming here, man.
That's good. Yeah. Good. Where are they? Are they coming or not?
They said they will discuss for 5 minutes and then they will come back.
Yeah. Let's go. Who is there? No one.
Now no one, yeah. But you can see the audience, right?
No.
Yeah, I put another. If you go to on the Zoom.
Huh?
Yeah, on the Zoom I put 2 cameras.
Ah, so then I have to change. Wait.
Yeah, Alan is here.
No. Ah, yes. Ah, with the other account.
Italian mafia. Ashley.
Is Alan?
Yeah.
Ah.
Hola.
Hola. Enhorabuena.
¿Vas a ir al Ápero?
No, estoy en Italia.
Ah, ok.
Sí, que vuelvo la semana que viene.
Ah, ok.
¿Hasta cuándo te quedas en Ginebra?
Bueno, noviembre, creo.
Ok. Perfecto, así nos vemos.
Sí.
No. Better for us, I think.
no, more another topic. I was thinking you could somehow, I'm just talking out loud, not I don't know what I'm saying, but you could also add the user somehow, not individualize solutions, but somehow you can profile the users based on preferences, location, stuff.
Do some
you can have
classification.
clusters.
Yeah.
You can have clusters, so your system could learn perhaps not to satisfy the particular needs of one user,
With the group
but
of
a
users.
group of users with similar, and so your system is more resilient in that sense or more.
Sure.
And so it's somewhere in the middle, it's not individualized, but also doesn't have these constraints that it's one solution for all. And from what I understood, your learning algorithm will adapt easily, which is more conditions.
Yeah, in this case, we will have two learning modules separate. One for the agent and one for to classify users.
Yeah, for example.
Yeah, could be.
Steps.
On leur a dit, nous, de revenir.
De se connecter sur le Zoom public.
Ok, d'accord. Moi, je vais reconnecter. Je vais reconnecter.
On vous envoie un email.
En tout cas, c'est quelque chose qui est revenu dans la nouvelle.
C'est un mauvais zoom.
Elle était revenue dans mon zoom.
Bon, ça. Non, je veux juste enlever le partage.
Ah, c'est moi qui contrôle.
Ah. Voilà. Voilà. Alors, ça quand même. Ok. Il nous manque encore 2 membres du jury.
J'ai envoyé
Ouais. On y va.
You should receive tu as l'email, tu as reçu quelque chose de...
No?
Nice one. Voilà, welcome back. Okay. So, after convening, the jury and considering your manuscript, your presentation today, and the work that you've done, you are awarded the title of Doctor in Information Systems from the University of Geneva. Congratulations. Thank you. So the jury appreciated your presentation, the quality of the manuscript, the answers that you gave, and the discussion that were conducted during this presentation. Also, the contribution to the state-of-the-art in collective adaptive systems. And the work that you've done is quite an achievement, and so for all that, congratulations, and all the best for the future. Thank you. Action.
Thanks to everybody.
Congratulations. Thank you.
Congratulations. There's no cakes today? So, where's the cakes?
So, bye-bye. Thank you.
Thank you. Bye-bye.
See you soon, I hope.
Thank you, Glizes.
Thank you.
See you around again, yeah?
Why not? Bye-bye. Bye-bye, everybody.